which measured the impact of the mix in each of the 12 impact categories that were, like, for example, the ozone layer, a hole, or the global warming. These kind of impacts, they were measured using a life cycle analysis. There is an analysis from cradle to tomb, analyzing the whole process. Just to give you some ideas of how the objectives were, in yellow we have the vulnerability, the amount of fuel imported, and then we have fixed cost in blue and variable costs in purple. So it seems that renewable sources are cheap, but they're not, because of these two things that are the power coefficient, that is how much percentage of the energy is actually turned into electricity, so that's basically the efficiency of the system, and then the availability coefficient, how many hours of the year do we have this source available. So this is actually what makes them costly. And for the environmental impacts, these are the impacts of the renewable sources. The photovoltaic is the one that has the highest impacts. This is not because the panels themselves pollute, but it's because the life cycle analysis considers the whole procedure, and building the panels is a very energy-consuming process. And then we assume that this energy is generated with the current mix, and that's why the process of the panels pollute. But still, when we compare this with the non-renewable sources, we can see that the impacts of the other ones are much higher, okay? So the problem itself, like I said, looked harmless, was not very difficult. It was a linear model with 116 variables, a little bit more than 1,000